Hi, in this video we will see how does AWS EKS Karpenter works for persistent volume claim on Kubernetes cluster. So here I'm going to show you with an example AWS EKS cluster containing Karpenter, the infrastructure already installed on that. We will see how does this Karpenter helps us to basically achieve the scenarios where pod demanding the persistence volume, that is basically PV on the nodes. So whenever we do a deployment of an Kubernetes application on the EKS cluster, right, say something like this, and the pod needs the storage space where it can store the data of its own application. So we call those the storage space called as a persistent volume, right? So as soon as there is a pods gets running, basically Karpenter under the hood, it detects that there is a need of persistence volume. Then Karpenter helps to create the the data storage and actually maps on this particular part so that pod can access that storage space or persistence volume and try to basically try to do the all those application functionalities as well. So here what happens is so we will have a demand for the persistence value that it gets raised by the pod, and that gets listened by the Karpenter, right? So and henceforth the Karpenter will invoke the PVC, that is basically persistent volume claim, which actually in turn provisions the required the volume that is required for this the pod, and henceforth the pod goes in a running state. Similarly, in a situations where where you don't have the persistence volume available, in such cases pod might go in a pending state, which means that pod is expecting a kind of volume storage, right, but it is not able to get it, right? So here we will see how does these scenarios will be mimicked at AWS EKS. So basically there are a hell lot of application which needs this kind of configurations, that is basically a need of persistent volume for application transaction purpose or application data storage purpose, right? So here we will see from scratch to end how to set up the your a cluster, so that the whenever you do a deployment, automatically PVC will happen, that is persistent volume claim will happen, and eventually persistent volume will be provisioned and mounted on the pod as well, and pod tries to use those for its application, and you will see that application running as expected, right? So here with that note, let me take you to the my Visual Studio Code. So this is my Visual Studio Code where I have articulated the steps that we needed to demo this particular scenario here, right? So that is persistent volume topology, right? So here what I do is I'm not gonna go from scratch to end. Here we will start from a scenario, or we will start from a stage where you have the AWS EKS cluster, and EKS cluster is already configured with the Karpenter, right? So if you don't know how to do this, please watch my previous Kubernetes videos on Karpenter, where I have shown multiple times from scratch to end, like how to create the Kubernetes cluster, how to configure the Karpenter on that one. So once the Karpenter is been up and running fine on the EKS cluster, then we will start with the scenario of persistent volume topology demo, right? So here we are in the stage where cluster is up and running fine, and then the Karpenter is installed. Now we are looking at the scenario how the persistent volume claim works on the Kubernetes cluster, right? So before I jump to the demo, so let me show you that my cluster is up and running fine. So this is my AWS account, so where my the Karpenter demo EKS cluster has been created. Currently I'm in Oregon region as well. So if I go to the CloudFormation template, because I have used EKCTL to create the cluster, so you see that I have the Karpenter demo the cluster CloudFormation template is already there, so right. So this is basically prerequisite. Now we will directly jump for the persistent volume here. So anyways, I have a help file.txt file which actually articulates all the steps that you need to follow, including how to create the the Kubernetes cluster as well, and then how to configure the Karpenter on that as well. So okay, so now we are done with the Karpenter here. If you see here, so when you run the command, that is helm list Karpenter or kubectl get pods from the namespace Karpenter, if you are getting all the Karpenter pods up and running fine, which means that you are done with the prerequisite. Now let's go to the next steps to demo this scenario, that is persistent volume. So let me make it bit broader here. I have already executed. Now I will take you I will make you to understand what does that happens under the hood, how does that basically the persistent volume claim works under the hood. Okay, so here next, once the Karpenter is up and running fine, we need to have a EBS CSI Driver installed on the Kubernetes cluster. So to do that, first one, you make a variable called cluster name, something like this. Since my system is Windows, so here I have created a variable cluster name, that is my cluster name. And then we gonna associate IAM OIDC provider on the EKS cluster, which means that you are actually federating the access on the Kubernetes cluster. In the sense, being within the Kubernetes cluster environment, you can access the AWS environment with through a federated access, that is OIDC provider method. Yeah. So for that case, we need to run the command kubectl utils associate IAM OIDC provider, region name, cluster name, and approve. Right. So if I run this command, so this is where the command I have executed. Okay. So here, try to follow the selection that I'm doing here, and you're gonna realize the how does that output also looks like. Yeah. So once I run this command, so I'm gonna get an output something like this. If I see here, that is IAM OpenID connect provider is already associated, because it's already associated by the virtue of Karpenter creation. That's the reason it is showing you. But this is very important step. You must need to run one more time. Yeah. So that you make sure that IAM OIDC provider is already there. The next one is we need to have a service account in the cluster, right? Remember that here I'm not using kubectl commands or Helm charts to create these OIDC provider and service account, but we are using EKCTL. So I'm using the EKCTL utility, which becomes a prerequisite here. So EKCTL is nothing but EKS command line utility, which is again a one more utility that you need to have installed in your system. Then it's gonna give you a CLI called EKCTL, through which you can interact with the the EKS cluster with using EKCTL, right? Like just like the kubectl or Helm commands like that. Yeah. Okay. So the next one is we are actually creating a IAM service account with the something name. So if you see my selection, so let me close this off for now. So anyways, don't worry. So that I'm gonna share this help file.txt file, which is a command file which can help you to understand what is happening in this one. And you can follow those steps as I demo in the video and try to replicate at your side and understand how does the the PV topology works in the Kubernetes cluster. Right. So let me make it bigger here. So here we are creating EKCTL create IAM service account. We are giving the name of the service account. A namespace is default, that is kube system. This is my cluster name. And I'm passing the AWS managed policy, that is Amazon EBS CSI Driver policy. And then this is the role name. So this is the role name, right? So it takes certain amount of time and then it gets created. That is, if you see here, so I know this is the basically service account will get created. Okay. Next one is, so the next one is create an add-on. So once the service account is ready, you need to create an add-on, right? So this step that we are doing right now is to enable EKS EBS CSI Driver on the Kubernetes cluster. Okay. So because that is a driver needed to orchestrate the PV topology activities in the Kubernetes cluster. So here EKCTL create add-on, that is of type EBS CSI Driver of AWS. This is my cluster name, and then we are passing the service account which we created above. Remember that here, if you see here, I have passed a variable that is account ID, which the variable was not defined, so it got an error to me. So this is basically a learning for you, in the sense how does that command works under the hood, right? So if you provide a wrong input, it will fail. This is a very good learning for you as well and for me as well. What I did is I later modified the command with passing the account number. This is my account number, by the way. And then you see that we are having, at the end, we were able to create the add-on, that is EBS CSI Driver add-on on the EKS cluster. And then I know I'm doing a basically validation whether the add-on is created on the cluster or not. So if I run a command, that is EKCTL get add-on from this EKS cluster, right? This is the cluster name and the driver name is this one. I should be able to get the driver something like this. You see that my output is currently in creating. So remember that before you go to the next steps, make sure that your driver is in active state. I did run the same command couple of times, that is couple of times here. If you see that it is still in creating, then I suddenly run it one more time again, that is same command, get add-on. What type of add-on? That is AWS EBS CSI Driver, that is name of my add-on from the cluster EKS cluster. And you see that you should be able to see that add-on is in active state. So okay, so with that, basically we have configured the EBS CSI Driver on the EKS cluster. Now we can go ahead and try to do steps, that is basically the declaring the storage class, deploying the the Karpenter definitions, right? And then basically deploying an application which will has the claim for the persistent volume. So let's see those. So for that case, I need the files. So let me make it quite change something like this. So here what we do is we're gonna also walk through the files which we're gonna use now. So let me close this off, and we're gonna rely on the commands which I have already executed. Okay, so slightly something like this. So now our EKS add-on, that is EBS CSI Driver, is up and running fine. Now I need to create the storage class, that is EKS storage class. So if I go to the YAML file, so this is the YAML file which we are actually defining, and try to run this on the cluster so that it define the storage class. If you see here, the kind is storage class, and it is coming from the object, that is Kubernetes storage object, right? And the metadata, this is my metadata. Remember that my storage class name is MySQL GP2, because here I'm using the GP2 volumes. Okay, so and the provider is, who is the provider? That is EBS CIS AWS.com. That is nothing but Amazon EBS CSI drivers. And then parameter is like GP2 and encrypted. Yes, I wanted encrypted storage as well, that is volume binding mode, wait for first consumer, something like that. And then these are all the basically definition of creating the kind, that is storage class. So this is also a step that you need to follow. And for that sake, since this file, that is MySQL storage class.yaml file, was under the path PV, so I did a CD. If you see here, I did a CD, and then I run the command, that is create MySQL storage class.yaml. So it created the storage class for me, and then I did a describe the storage class by the name. So it described, if you see here, right? So it shows the information about the storage class. Okay, so with that we go to the next command. The next command is, you need to run this pv.yaml file. So basically remember that pv.yaml file is nothing but it's again the once you install the Karpenter software in your cluster, you also need to install the node pools and the ECS. Okay, so that's all these commands is telling all about. There is nothing magic, there is nothing different than what I explained in the previous video. So I'm going to skip it here. So basically it creates two resources. One is EC2 node class, and then the Karpenter node pools. So if I expand and then go back from where we stopped, if you see here, I'm running a pv.yaml file which created two Karpenter objects. One is node pool and EC2 node class. And then I'm creating the workshop. Because why I'm creating a new namespace called workshop? Because I need this the namespace for installing my application, which will actually has a claim for PV, that is persistent volume, right? So if you go here, right, okay, so next command is apply file called pv deploy. So here we are deploying an application, that is Kubernetes application or container application, where a deployment has a persistent volume claim. This is very interesting, and this is where basically application which has this kind of manifest file or specification needs a persistent volume that is required for application runtime purpose. So here also remember that here also we are declaring the persistent volume, storage class with the same definition as I explained here. That is so, but here the definition is allowed topologies of the EBS value, in the sense where does these EBS value has to be created. So these VBM value has to be created in a region where my cluster is sitting, that is in the US West 2. Here we are providing the basically the region availability zones. Okay, that's what it happens here. And this is the magic happens basically whenever you do a deployment and that needs a volume to be attached to for a application runtime purpose, you should create a kind called persistent volume claim, and the claim name is something like this. If you see here the name, so what is the persistent volume claim is nothing but it's kind of a invocation. If I go back to the diagram, so here if you see that the pod will have a persistent volume claim, that is PVC, right? So if I delete all these so if you see the the naming convention, that is I have defined. So here you see that, so whenever the pod is deployed, it's when it about to run, it actually invokes the PVC, that is persistent volume claim, and persistent volume claim channelizes it to create a PV, that is persistent volume. And that is what the connection is here. So first one, we will create a claim, and that claim will be passed to the application deployment, or basically deployment, yeah. And in the claim you have some certain specifications, that is access mode should be read and write, and the storage class nothing but so basically so before you use a persistent volume, you need to create a storage class Kubernetes object, and that is where we are pointing it here. And then comes so what size of the storage that you need, that is nothing but 4 GB, right? And then comes the default the application deployment, that is nothing but container application deployment, right? So now You created a two object. One is basically storage class, the other one is persistent volume claim. Now you are using, basically you use the persistent volume claim while you are deploying the pod, right? So what is the pod? So remember that whenever you say pod, how does that pod is created? Pod is created by the Kubernetes object called deployment. When you do a deployment or application deployment on the Kubernetes cluster, that's where pod gets created. And how does that pod gets created? That is will be defined in the specification definition of this particular Kubernetes object, right? So basically a deployment has a metadata. In the metadata, you define that, what is your deployment name and what is the way this deployment has to happen. This is at a higher level configuration definitions. And once you define the container, that is your namespace and the name of the deployment, you need to go one more step. That is, within the deployment, what are all the objects that you are creating? So here you are creating the pods. So replica tells like, what is the number of pods that you need to create out of this deployment, that is 2. Then we have a selectors, in the sense if somebody has to reference these pods, how do they reference? They reference by a match label called app key and value equal to inflate. And then template, so through which template they have to create it. So basically template reference is again, so this is where the template reference is all about. In the, basically within the specification, you also have a specification within the template, which actually tells you like, how does that pod has to be created. So here we have a termination grace period equal to 0. Container equal to, this is where you are actually creating the pod. We are using the CentOS and creating the pod. Within this image, we are actually running bash script, and the argument is something like this. Is basically a shell script which always which always runs a certain commands, and that command will be stored in out.txt file. Remember that data is nothing but what? So let me tell you. So basically data is a persistent storage path where this particular volume is mounted. In the sense, you have a disk, that is EBS volume. The EBS volume is mounted on the pod. Nothing but pod can access that. Yeah. And so to basically to that, underneath that path, we are actually creating the files, that is nothing but out.txt file. So how is that possible? If and only if there is a volume is being mounted on that path. And that is where volume mount definition talks about. That is, it needs a persistent storage volume onto a path like data, and it needs a resources of request equal to CPU1. And the volume definition. So how does this volume mount will be created? This is coming from persistent storage, and where is the volume claim? So this is the volume claim, right? And then nodes space selector, basically in where this pod has to be deployed. This pod has to be deployed from a nodes created by Karpenter. Remember that since we are using Karpenter here, that is acting as a the application the infrastructure layer that sits on the Kubernetes cluster and orchestrates our applications. And that's the reason this pod gets created in this particular node, that is EKS immersion team, that will be defined here in the when you create a node pool, right? So when you create a node pool, you see that you have a immersion EKS labels. And so basically these are all, I'm going to show you that a while. So that is where basically definition is all about, right? So if you see here, so in the specification, this is very important, or basically heart of the demo. So in the specification, you are doing us two definition. One is volume mount, and other one is the volumes. Okay, so if I minimize this, basically names. So underneath the containers, so underneath the container, you are telling that hey, I need a mount of certain certain names and certain the types, and the volume definition will be retrieved from the claims, something like this. Okay, all right. So this is what our PV deployment file definition. I did run this command, that is kubectl apply PV deploy, and it created basically it created a storage class. It created a basically, if you see here, it created a persistent volume claim as well. It created a deployment. Okay, so if you see here, these are all the complex resources created in the cluster, but with the warning. So you see that there is a warning. So what does that warning tells is basically you are deploying an application that is needs a storage class of something, this one, but it is missing in the Kubernetes class. Okay, that is what warning it will be telling, right? And then that's where if I go back to the diagram, that's where the Karpenter plays a role, right? So Karpenter will virtually, it is orchestrating the the demand of the pod for persistent volume claim. How? Because Karpenter is incorporated with the Kubernetes volume binding, right? With that approach, basically under the hood, it is actually fulfilling the request or demand by the the pods. Okay, so that is where if I go back to again, so if you see that I was tracking the logs of the Karpenter the pods, and you see that there are certain like created node claim, right? And you see that there are like an instance class, and it also talks about basically there was a there is a persistent volume claim as well. So you can track these logs, and where you can find that Karpenter is helping us to get that get the values that is needed for pod to run. Then I run a command that is called kubectl get pods, which is actually tells me that tells that these are all the two pods, that is inflate pods are being created for us. So if I go down and try to get all pods from the workshop, the namespace, my pods are running. Remember that pods won't be running if the volume claim is not fulfilled, right? So that's it. For that check, what we do is we need to know the node names. Okay, so you can run a command that is kubectl get pods. Output is basically the column that is node, in the sense you also get me the node name from the metadata names. Yeah, and this is where I got the pod name and the node name. Then what we did is I'm very curious, and I want to know whether the pod has mounted with the certain volume claim. Kubectl describe pod, basically if you describe it, you see that you can see that there is a volume attached to this one, right? Let's see where does that. So if you see here, there is no replica, default, nodes. If I go down, you should see that there is a volume claim. Okay, so here it is, right? If you see here, there is you see there is a there is a event called EBS volume claim. This is okay, so this is basically, if you see here, successful attach, right? So if I go to the event, this is basically event tells that the request for volume, right? So this is warning, this is normal, this is success. Basically you see that there is a demand for attach a value, but we can define where is the value, right? So till now we were actually, so basically what does that mean is basically Karpenter has provisioned the required volumes that is needed for the pods. Okay, so now what we do is, now we're gonna do one more step, that is if I go back to the pv-deploy.yaml file. So pv.yaml file, in the pv.yaml file we are running one bash script which actually writes a certain sentence in a path that is mounted on the volume, in the sense that the certain files will be created, and that file will be written with a certain certain lines, right? And that file is stored on the path, basically belongs to the EBS volume only. So to get that output, you can run a command called kubectl namespace workshop, execute this pod, and try to get what is the content into this particular output. So if I rerun this one, so you can see the output as well. So here you go, right? So it is basically, it contains so many lines. It's keep on running. So let me rerun it again. So how is this possible? This is only possible because if and only if we have a path called data and then output.txt file, which means that it is running, right? Let's run, let's try to do a certain further testing, whether how does that volume looks and what all happens. So I have a few more commands to show you in front of you only. So we did run this that is kubectl namespace workshop, and we executed certain commands by logging into the pod. Okay, so basically this is what we did. So remember that exe is nothing but you are actually remotely running a certain command on the pod as well. All right, so next one is to identify get PV. So let's see how many persistent volumes are there. So if I maximize this, here you go, right? So we have a persistent volume, that is basically, this is the name. Yeah, this is the name, and size is this one. Claim is workshop EBS. Storage class is MySQL GP2, right? So this is the PVC which is attached. Now you can also check one more deeper, that is what is the persistent volume. Basically to check the PVC claim, do we have any PVC claim? You can also check that there is a PVC claim basically happened bound, in the sense you see that application has demanded a PVC that is persistent volume claim, and it is status is bound, in this nothing but it bounded, it's binded on, or basically it's attached basically like that. Yeah, bound is nothing but attached. Okay, so now next one, let's go to the we did describe the part as well, that is nothing but kubectl get provision. Okay, so we can also get let's see if this command works, which actually describes the persistent volume as well. So you can also run a command something like this, kubectl get persistent volume, that is output, and then you are describing that particular persistent value. So if you want to know more details about our persistent volume, so you can run this command, that is kubectl describe in braces kubectl get pv, that is output name. And here you go, right? So this is our persistent volume name. You have these many annotations, right? And then it comes the the status, the storage classes. This one bound is status, right? These are all the policies. So blah blah thing. So basically it has a very, the required informations are already there, right? Let's go to the next command, that is let me run the next command here. All right, so let me go to this one and go to the help file. Okay, so we are done with. So now what I do is I'm gonna do one more test here. That is basically, let's delete all the pods and so that it gets created again. And then we will see that we will have a one more the node claim, or basically PVC claim. Okay, so what I'm doing is I'm deleting all the pods, that is 2 pods, right? And then so once you delete the pods, basically so as you know that pods are ephemeral, and then the Kubernetes is an orchestration solution which will identify that certain desired state on the on the cluster, right? That is defined in the deployment. If that desired state is not there, the basically container will recreate those pods. Okay, now we deleted it abruptly, but the the Kubernetes will automatically create those pods. Let's see if we have the pods back. Here you go, it happened, so if you see here, it happened just like that, right? And then okay, so this is readiness is none. Yeah, status is running, which means that it has happened very quickly, right? Let me try to rerun it. It's I don't want to be wide. Just get the pods, okay, and let's see. So if you see here, it's running and the age is from 56 seconds, which is just now, right? So what did I mean is basically I wanted to show you that parts are basically ephemeral, which means that they are deleted, but they are again created by the containers or Kubernetes orchestration. Now what we do is we're going to do one more step, that is basically get the name again. So to get the name, so this is Windows system, so I don't want to run the I don't want to run the basically the shell scripting command. So basically I need to run like this, that is to get the pod names. So these are all my pod names, right? So I'm going to remove this off, and then yeah. So then again, what we do is we're going to run the we're going to run the command, that is we're going to run the remote execution command, which will help you to get the output of the out.txt file. So for that region, let's try to run this command something like this. So don't run it this one because we don't have a variable called pods. So for that case, let me copy this from here, and then if I go here, right, and try to run this command, kubectl namespace workspace, right? So here you go, right? So it started to basically even though the we deleted the pod, again it got created, and the the uses of the persistent value that we have attached, it's in continuation, right? Now one more thing I want to show is let me go to the AWS EC2 instances. So this is AWS EC2 instance. Okay, so remember that whatever the Kubernetes instances or Kubernetes node that we're creating here are basically in the backend, they are basically they are basically EC2 instances. Here you go, you have the default nodes or instances created, and we have an instance created by the Karpenter, that is for deploying an application here, right? And then if you go to this, if you try to explore this one, you should be able to see the volumes attached to this one as well. So these are all basically the information about this one. You can also dig down and try to identify the storage. If you go to the storage, right, so we have a storage. If you see here, we have a storage here, that is 2 volumes are being attached. One is of size 20 GB and one is 4. So this is the one which which is got created by the claim of persistent value from the pod, right? And then that's where the data is getting stored actually. So you can actually it is attached to an instance, so you can also see the instance, which is basically the instance created by later stage. Okay, you can, okay, so let me go back to the volume. So this is the volume ID. So if you see here, so this is my volume ID, and you can also get more details about these volumes. So I click on that basically. So here is the detail, that is, remember that we have opted 4 GB the storage, or 4 DB disk in a very layman term. So that's what we have got, right? And yeah, so I have wanted to show you everything. So basically it is mounted, and the pod is also using. Yeah. All right, and you can also see the monitoring, where if you can see that there are in and out, that is basically input and output are operations are happening. So you should see some graphs as well. Why input and output is happening? Because our pod is continuously writing something on that particular disk. All right, so with that note, I have shown you from scratch to end in detail persistent volume on the Kubernetes with using Karpenter. Thank you very much for watching my videos. Kind request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you, thanks a lot, and see you in the next video.